our next speaker. Our next speaker is Dr. Colin Tan. Okay, Dr. Colin Tan, aka Polar Bear, due to his great size and his passion for raw fish. He's a senior lecturer right here at SOC. Okay, he graduated with a Master of Science in February of 2000 and a PhD in July 2004. His current research interests include defeasible reasoning, belief functions, speech recognition, and dialogue systems. Despite his somewhat simplistic appearance, Colin has a passion for religion and theology. He claims to enjoy reading Christian classics like Interior Castle, The Cloud of Unknowing, and The Way of a Pilgrim, trusting that no one will attempt to verify that claim. Colin loves animals and does not have any problem admitting that his favorite animal is the polar bear. He loves cats too. In particular, a 7-year-old feline named Kucinta. Okay, so presenting the topic droning, the trials and jubilations of unmanned flight, I present to you Dr. Colin Tan.
Okay, thank you. I can't believe that all of that made it in there. One sec, hold. Okay, now what's today's talk about? Nothing technical. Firstly, right, it's kind of about my experiences with unmanned flight. And basically, I wanted to be a pilot and I couldn't, so I got around that. And secondly, right, it's kind of about how all of you can get involved in building unmanned aircraft. Now, I've always loved flying. This is Flight Simulator 1, which I was playing with when I was 11 years old. I won't tell you how old I am. Flight Simulator 2. And now this is, I forgot what this is called, Explain. Okay, so now you can see it's kind of cool. Now, after I got my PhD, I sent in my application to be a pilot. So, you know, I was like kind of like this guy. I was going, yes, I can be a pilot now. And I saw this guy was so happy, but the response from SIA was sort of like this, quiet, you could hear the crickets chirping. So that didn't work, but I figured that's okay, because what I really liked was more of the challenge, and the fact that the flight deck is just filled with very cool toys. Okay? So that was my main thing about why I wanted to be a pilot. I really didn't like flying. So I figured, fine, what I'll do is that I'll build something difficult and I'll show it to people in airlines and then they will let me get onto the planes and put them inside. That, by the way, is the computer bay of an airliner. Now, unfortunately, right, airlines and aviation authorities think that if you just put stuff into their planes might end up a smoldering hole in the ground. Okay? So, anyway, as I said, they were afraid that I would turn the aircraft into a smoldering hole in the ground. So they put me, they said that, well, before you can put anything on, you have to do all of this stuff. DO-178B compliance, reliability, timing predictability. It was crazy. So I figured out, right, wait a minute, the authorities don't really care if I don't carry people on the planes. And even if I don't carry people on the planes, I can still do really, really cool looking stuff that look like that. Okay? So I figured, yeah, that's what I'll do. Now the first thing is, I need to choose an autopilot. I had a choice between a $28,000 thing that looked really, really cool and a $900 thing that is 100% open source and open hardware. Very tough choice. This looks so cool. Now that was one thing. Second thing is I had to figure out the choice between a $15 million aircraft that came with a very cool air-conditioned cabin for you to fly the plane, or this ugly thing over here, right, that came with absolutely nothing. Okay? Now, unfortunately, this was my vision. This really cool thing, and all of these men working for me, and this was the implementation. So I still have these two guys working for me, but it didn't quite turn out the way I expected it to be. Now, there was one problem. It was also hard work to get it up in the air. We had complex mathematics, we had complex architectures, and best of all, or worst of all, we had complex coding to do. Okay, so kind of a bit of a pain. Now we also had lots of testing in the field. These two guys, right, these two crazy looking guys, they are the guys who actually fly the plane. And you can see my colleague working in the field, subject to mosquitoes, sunlight and rain. Okay, so this was kind of a bit fun. Now, this user acceptance test on the 2nd of September, with all of the boxes and paymasters present, before the test, after the test. Now, as it turns out, it was my mistake because I had used a voltage regulator that was severely underpowered, overheated in mid-air, and shut down in mid-air. So we lost complete control of the plane, and this was kind of the end result. And now okay, so But 2 weeks later, we managed to get it back up in the air. The customer was happy, signed off on it. And we also got kind of cool technology out of it. Like this, right? It's actually technology to allow light aircraft to fly in the air in a more stable manner. Now, so that's about me. What about you? Now, you can do the same thing too. You can buy the kit online. It's $399. This is the GPS system. This is the GPS adapter. And we also have got these telemetry transmitters here that you can use to send data from the plane back down to the ground. There's an airspeed sensor. And right now, right, this whole picture has gone out of whack. Cost of the autopilot, $842. Okay? Now, what about the aircraft? You don't need a $15 million aircraft, which I kind of truly wanted. This guy over here is $250. Okay? So all in all, right, with just $1,095, you can build your own unmanned aircraft that will give you hours and hours of fun. Now, all autopilot parts can be bought from sgbotic.com, which is where I get everything from. Instructions are at diydrones.com. And this is the route from where we are right now to Fook Hai Building to buy the plane. But one serious thing though, I have to be the Asian dad and tell you this. Planes can crash into houses and kill people, so please be careful. Either learn to fly these planes well or get someone to do it for you. Thank you.